Hi everyone, welcome back. Today we're going to be looking at standard 6.ee.a.1, write and evaluate numerical expressions involving whole number exponents, and 6.ee.a.2, write, read, and evaluate expressions in which letters stand for numbers. So our two primary terms are expressions and equations. An expression is a mathematical sentence that does not have an equal sign, whereas an equation is a mathematical sentence that has an equal sign. Okay, so as outlined in the example here, 3x minus 5, there is no equal sign, but for the equation 3x minus 5 is equal to 10, the equal sign is what makes this an equation. Let's take a look at the parts of our expressions or equations. So we're going to use this example up here, 2x plus 3 plus y minus 4x plus 7y squared minus 10, to help us identify the examples for our coefficient, our variable, our constant, and our term. So a coefficient is a number that is multiplied by a variable. It is located in front of the variable. So if I look at my terms here, I look at 2x and I see that there is a number and a variable. I look at the y. I don't see a number, but I do see a variable there. Negative 4x and positive 7y squared. So when I look at 2x, based on my definition, the number 2 would be considered a coefficient because it's located in front of a variable. Now when I look at y, I don't see a number there, but there is an invisible 1 that exists because 1 times anything is itself. So 1 would also be a coefficient. Negative 4 would be a coefficient when I'm looking at negative 4x, and positive 7 would be a coefficient in 7y squared. Now variable, a variable is an unknown value represented as a letter. So when I go back, the letters that I see in my expression are x and y. So those are my variables. A constant is a term that does not contain any variables, and the only two terms that I see are positive 3 and negative 10. So my constants are positive 3 and negative 10. Now for my terms, it says terms are parts of an expression or equation separated by operations, and the operations that we're referring to here are addition and subtraction. So based on this example, that tells me that 2x is a term, positive 3 is a term, positive y is a term, negative 4x is a term, positive 7y squared is a term, and negative 10 is a term. So all of those values placed together by addition or subtraction are considered terms. So I'm going to list them all here. Okay, and then our like terms, we'll talk about that a little bit further in our lesson. So let's take a look at these examples. It wants us to identify the terms, our coefficients, our variables, and our constants. So for example number 1, there are 1, 2, 3 terms, and the terms are 12a, negative 6b, and positive 4. My coefficients are 12 and negative 6. Both of those are attached by multiplication to a variable. My variable, or variables in this case, are a and b, and my constant is the number 4. It's the only value that does not include a variable. For number 2, there are 2 terms. 4x is one term, negative 2y is my second term. My coefficients are 4 and negative 2. We always want to include whatever sign, whether it be addition or subtraction, that's in front of that term with the term. So this is a negative 2y, that's a negative 6b, that's a negative 32. Subtraction and negatives, they are pretty much synonymous. So you read it as c minus 32, but if we look at it independently, this is a negative 32. Our variables are x and y. And in this example, we have no constant. For number 3, we have two terms again. We have c and we have negative 32. There is not a number in front of c, but we know that there is an invisible 1 there, so that's 1c minus 32. So my coefficient for this example would be the number 1. My variable is c, and my constant is negative 32. Let's go ahead and take a look at number 4. Number 4, 3x plus 2. Again, I have two terms, 3x and plus 2. My coefficient here is just the number 3 because it's attached to the x. My variable is x, and my constant is 2. Now we're going to look at this Fourier model to explore the term like terms. So like terms is defined as terms that have the same variables raised to the same exponents or power. The characteristics, same variable, same exponent, different coefficients. So it can have the same coefficient or different coefficients. The coefficients does not matter. And they can be added or subtracted. So some example of like terms are 2x plus 4x. They have the same variable of x and the same exponent of 1. A non-example would be 2x plus 4x squared. One of them is raised to the second power while the other is raised to the first power. Another example would be 7xy plus 3xy. If you notice again, there are two variables on each of them, but the variables are the same. A non-example would be 7xy plus 3x squared y. We have the same variables, but now the x is raised to a power of 2, while the x in the 7xy is only raised to the power of 1. We can even go a step further and include 11yx. Here the variables are placed in a different order, but the variables are still the same because with multiplication the order does not matter. So I could rewrite this as 11xy and it would be the same as the other two. So this would still be considered a like term to the others. Negative 20 plus 3. Both of those are constants. Constants are like terms. However, 3 plus 2x are unlike terms because there is an x here on the 2. Okay, so these are just a few examples of like terms and a few non-examples of like terms so that you can see the difference between the two. All right, so let's go ahead and identify some like terms. At the base of our tree, we see that we have the variable y, x squared, z, and 8, which is our constant. So we're going to go ahead and use this bank to fill in the missing values in the tree. So the like terms of y, again, it must have the same variable, same exponent. The coefficient can be different. So I see y here. We're going to go ahead and write that in. 9y. Another 9y. 3y, 11y. Okay. We could not use xy because x is another variable and that's not a like term. Let's take a look at our constants. So 8, I see 7, I see 19, and I see 11. For z, I see 7z, I see 2z, I see 5z, I see another 2z, and I see 4z. Okay. Now for x squared, I see x squared here. I see 6x squared. And I see negative x squared. Okay. So that tells me that those are the like terms. I cannot use that 9x with the x squared because it does not have the same exponent as the others. All right, so for example B, we're going to shade. So let's start off with our constants. Okay, so negative 48, another one is 8, 1/2, 6. And you can pause and try these on your own and then check to see if your answers match mine. So I think that's it for our constants. So let's go ahead and change our color. And then let's take a look at the y's. So I have 5y, I have 7y, I have negative 3y, positive y. And I think that's it for my y's. Let's go ahead and take a look at my x squared. So I have 7x squared, I have 2x squared, I have negative 15x squared, I have negative x squared, I have a positive x squared here, and I think that's it for my x squared. Let's take a look at my x to the third, or x cubed, so 4x cubed, 2x cubed, negative 3x cubed, positive 8x cubed. Okay, those are my like terms. Then let's take a look at my y squared. So I have 1/4 y squared, I have 2y squared, I have 9y squared. And then I believe what's left over are all like terms. So that's my 3x, my positive 2x, and my negative 5x. Okay, so those are all of my like terms. So let's take a look at combining like terms. Our steps for combining like terms. Step 1, identify the terms with the same variable and exponent. Step 2, use different shapes to identify the like terms, and those shapes can be a square, a rectangle, a circle, triangle, so on and so forth. Perform the operation add or subtract using only the coefficient, and then simplify. So let's take a look at our first one. So I have x plus y plus z plus z. The only things that I see that look the same are my z's, so I can go ahead and put a circle around them. Now remember we talked about if there's not a number there, there's an invisible 1. So to combine these, I would say 1z plus 1z is 2z. And then I'm going to carry down my other values. So plus x plus y. Now this could have been rewritten as x plus y plus 2z, and that would have still been correct because my values have the correct signs associated with them. Let's take a look at the next example. So here I have y minus 2 plus 5 plus y. So I have y, that's the same. And constants are also like terms, so I can put a shape around those as well. Now if you notice, I included that negative sign in my rectangle with my 2 because that sign is associated with the 2. So now let's go ahead and combine. So positive 1, positive 1. So that gives me 2y. And now I have negative 2 plus 5. So these are different signs. When I have different signs, I subtract and keep the sign of the larger number. So 5 minus 2 is going to be 3, and a positive is associated with the larger number of 5. So my final answer here is 2y plus 3. Let's take a look at our third example. So I have negative 7x squared plus 2x plus 4x plus 3x squared. So all of these have x's, but if you notice that the exponents are not the same. So my negative 7x squared would be like terms with my positive 3x squared, and my positive 2x would be like terms to my positive 4x. And we can go ahead and combine those. So I can rewrite this so that they're together. So negative 7x squared plus 3x squared. And then positive 2x plus 4x. So I changed my colors here just so that it's easier for you to differentiate between what's being added. So positive 2x plus 4x is a positive 6x. And then negative 7x squared plus 3x squared. So here we have different signs, so we're going to subtract and keep the sign of the larger number. So that would give me a negative 4x squared. And that would be our final answer. Because these are unlike, I cannot combine them any further. All right, let's take a look at one more example. So this example is asking us to describe and correct the error. So here we're given 3x minus 5 plus 2x squared plus 9x. And this is equal to 3x plus 2x squared plus 9x minus 5. So this person rewrote it. Okay. And they said that the like terms are 3x, 2x squared, and 9x. Now, if you remember what we talked about, like terms must have the same variable and the same exponent. Therefore, this is incorrect. 2x squared is not a like term to 3x and 9x because these have an exponent of 1, whilst 2x squared, the exponent is 2. Okay? If we wanted to go ahead and simplify this, we would say, so I'm going to rewrite it, 3x minus 5 plus 2x squared plus 9x. Our like terms are positive 3x and positive 9x. So we can combine those. 3 plus 9 is 12x. And then I bring down what I have left. Okay, I'm going to rewrite this with my highest exponent written first, so 2x squared. Then I'm going to write my other value with my variable plus 12x. And then I'm going to write my constant last. Okay, thank you for watching and have a great day.